Okay, so are you ready to dive into the mind of a math rock star?
I'm ready.
This guy, Leonhard Euler, was like publishing 800 pages of
Yeah.
groundbreaking math a year,
Oh, yeah.
even after going blind. We're
Incredibly.
talking 18th century.
Titan.
His work is like the foundation of math as we know it.
It's
You
true.
probably use his work every day, and you don't even realize it.
Without a doubt.
You've got some pages there from a Spanish biography of Euler,
Uh-huh.
and we've translated the excerpts you marked, and
I have.
we're going to unpack some serious aha moments about his contributions to analysis,
Definitely.
number theory,
Oh, yeah.
even like the quirky side of math.
He was a fascinating character.
So whether you're brushing up on calculus
Mm-hmm.
or just fascinated by prime numbers,
It's all there.
get ready for some mind-blowing insights.
You got it.
And trust me,
Okay.
even if math wasn't your favorite subject in school,
Right.
Euler's story is one that'll make you appreciate the power of curiosity
Totally agree.
and sheer genius.
Sure.
To really understand his impact,
Yeah.
we need to start at the beginning.
Okay, let's do that.
Born in Basel, Switzerland.
Basel, Switzerland, that's right.
And his father was a pastor.
His father was a pastor, but he had...
Hold on.
Yeah.
A pastor dabbling in math.
Yeah.
That's not the usual Sunday school lessons.
Yeah, your typical Sunday school lesson, but Euler's father was actually taught by Jacob Bernoulli.
Oh, wait.
Yeah.
The Bernoulli family.
Mm-hmm.
They were like mathematical royalty.
Yeah, the Bernoulli family were like mathematical royalty in their time.
That's a huge connection.
Oh, yeah, and this connection was really important for young Leonhard.
Wow.
Yeah, it was actually Jacob's younger brother, Johann Bernoulli, who became Euler's mentor.
Oh, wow.
And that really sparked his lifelong passion for analysis,
Analysis.
which basically the study of how things change,
Okay.
a pretty big deal
Yeah, that is a pretty big deal.
in math and beyond.
So we've got the family ties to math superstars. But was there anything in his early life that hinted at the sheer genius he would unleash?
Well, there's a cool story that gives you a glimpse into the world of math back then,
Right.
even before Euler was born.
Really?
Johann Bernoulli challenged the entire math community
Wow.
to solve a problem called the Brachistochrone problem.
Perkisto. What?
Brachistochrone.
Sounds intimidating.
It's a fancy word, but it's a simple idea.
Okay.
Finding the fastest path between 2 points.
Oh, okay. So like a roller coaster track.
Exactly.
What shape gets you from A to B in the shortest amount of time?
Exactly. That's it.
Oh, that's kind of cool.
Yeah. And the solution to the problem turned out to be a curve called the cycloid.
Okay.
And this just highlights the sort of puzzle-solving competitive spirit that was really at the heart of math back then.
Yeah.
And this was the world that Euler was about to just take over.
And this pastor's son, despite his father's wishes for him to follow in his footsteps,
Well,
just couldn't ignore the call of the mathematical wild.
you could say that.
But before we get to like his groundbreaking discoveries,
Yeah.
it's important to appreciate how much he shaped the language of math itself.
Oh, this is key.
Like, we take so much of it for granted today, but he was really the architect
He was.
of how we express mathematical ideas.
Mm-hmm.
So he's not just solving the problems.
Yeah,
He's giving us the tools to write them down
exactly.
and understand them.
Mm-hmm.
Tell me more.
Okay, so take pi, for example.
Okay.
We all know it's about 3.14.
Yeah.
Has something to do with circles.
Yeah, of course.
But Euler popularized using that Greek letter pi
Oh, really?
to represent this constant.
Wow.
It was used before him by William Jones, but Euler made it universal.
So he gave it like celebrity status?
Yeah, exactly. He made it famous. But it wasn't just pi.
Yo.
He had a knack for symbols.
Okay.
So he also gave us E, the
Yeah.
base of natural logarithms.
Oh, logarithms. I'm getting flashbacks to high school,
I know, right?
and they're not good.
But what's important is that he recognized the significance of this special number E,
Okay.
and he explored its properties and essentially gave it a name.
Okay.
And here's the thing. No one really knows why he chose E.
Really?
It's one of the great mysteries.
A mystery.
A mystery in math.
You've got my attention now.
All right, so pi and E are in his toolbox.
What else?
He gave us I for the imaginary unit.
That sounds kind of imaginary.
It does, right? It sounds imaginary.
Yeah.
But it was a total game changer.
Okay.
Before we were stuck in the world of real numbers.
Mm-hmm.
But this symbol opens up this whole new dimension.
Yeah.
It allows us to work with complex numbers.
Okay, so he's not just shaping the language of math.
Yeah.
He's like expanding the universe of numbers we can even think about.
That's a great way to put it.
This guy's on a roll.
He's just getting started.
So he's got pi.
Mhm.
He's got E.
Yes.
He's got I.
He does. He gave us sigma, the symbol for summation,
Oh, yeah.
which makes working with series, those infinite sums,
Yeah.
much easier.
Okay.
And remember, Euler was a master of series,
I'm learning that.
as we'll see later.
It's like he's the Shakespeare of math.
I love that analogy.
Giving us these words and symbols to express complex ideas in a way that's both elegant and powerful.
Absolutely.
And he even standardized notations for things like triangles,
He did.
using lowercase letters for sides and uppercase for angles.
That's right.
To make it clear what we're talking about.
Exactly.
Yeah, that does make it way more clear what we're talking about.
He did the same for the radii of circles with big R and little r.
Okay.
And these might seem like small things, but they brought so much order and clarity to math communication.
It's like he's tidying up the entire house of mathematics, making it more organized,
Yes.
more understandable,
Right.
setting the stage for even greater discoveries to come.
For sure.
This is just the beginning of his epic journey.
Oh, yeah. We're just getting started.
At the age of 20, he joins the St. Petersburg Academy.
Wow, 20 years old.
And that marked the beginning of like, mind-blowing productivity.
Oh, yeah, this guy was a machine.
Okay, so St. Petersburg Euler. The stage is set. What happens next?
Let's find out.
So last time we left off with the young Euler arriving at St. Petersburg Academy, ready to unleash his mathematical genius on the world.
Ready to go.
So what were some of the first big problems that caught his eye?
Well, one of the first challenges he tackled was this problem of interpolation.
Interpolation.
Yeah, imagine you have some data points.
Okay.
Measurements, observations, whatever.
Mm-hmm.
And you want to find a smooth, continuous function that fits them perfectly.
Okay.
That's interpolation in a nutshell.
Okay, so did he just come up with like a really good interpolation method?
He did something even better.
What?
His work on interpolation led him to discover this thing called the gamma function.
Gamma function.
Yeah, and it's become a cornerstone of advanced calculus, and it has applications in fields you wouldn't even expect, like statistics and physics.
Wait, so something that started as like connecting the dots ended up with implications for understanding the universe.
It really speaks to that interconnected nature of math.
Yeah.
And Euler had this uncanny ability to see those connections, to build bridges between these seemingly isolated concepts.
Wow.
But he didn't stop there.
Okay.
Euler also had this knack for taking on problems left unsolved by other mathematicians,
Okay.
like a challenge issued by Pierre de Fermat.
Oh, Fermat, the guy with the infamous last theorem.
That's the one.
That took centuries to solve.
That's right.
What kind of puzzle did he leave for Euler to untangle?
So Fermat had this idea that a certain type of number was always prime.
Okay.
These numbers are of the form 2 to the power of 2 to the power of n plus 1.
Okay, can we just say they're a special family of numbers that Fermat thought were all prime?
Yes, exactly. It was a bold claim,
Yeah.
and for a while it seemed to hold true.
Mm-hmm.
But Euler, being the meticulous genius he was, wasn't satisfied. So he dug deeper, crunched the numbers, and he discovered a clever way to factorize one of these Fermat numbers.
What?
Proving that Fermat's conjecture wasn't always true.
So even the great Fermat could be wrong?
Even Fermat.
And Euler was the one to set the record straight.
That's right.
That must have been a pretty satisfying moment for a young mathematician.
I'm sure it was.
It must have cemented his reputation as like a rising star.
Oh, for sure.
And during this time, he was also solidifying his legacy by giving a name to one of the most important constants in mathematics.
Oh, yeah. E.
The base of natural logarithms.
We've talked about E earlier, the mysterious symbol with the unknown origin story.
Right.
So did Euler discover E or just give it its official name?
He didn't actually discover E itself.
Okay.
That credit goes to someone else.
Okay.
But Euler recognized its importance, and while working on logarithms, he started using the symbol E consistently. Calculated it to 26 decimal places, and really explored its properties.
Wow.
It's kind of like he adopted E.
Saw its potential
Yeah.
and helped it become the superstar that it is today.
Okay, so from connecting dots with the gamma function to debunking Fermat's conjecture and giving E its proper due.
Euler's killing it.
Euler's already achieved a lot in his early years at St. Petersburg.
He did.
But I'm getting the feeling he's just warming up.
You could say that his next achievement would launch him into the stratosphere of mathematical fame.
Really?
It all started with a problem that had stumped mathematicians for decades, the Basel problem.
Ooh, the Basel problem.
Yeah.
That sounds serious.
It does.
What was the challenge?
So the problem involved finding the exact sum of an infinite series.
Okay.
11 squared plus 12 squared plus 13 squared and so on.
Okay, so you're adding up like the reciprocals of all the squares forever.
It's it.
Okay.
So mathematicians knew the series converged.
Okay.
Meaning it approached a specific value, but no one could figure out what that value was.
So it's like an infinitely long math problem with an elusive answer.
Pretty much.
Sounds like a recipe for frustration.
It was a puzzle that had everyone stumped.
But Euler!
He tackled the Basel problem head-on and, to everyone's astonishment, found the answer.
Okay.
And it involved pi.
Wait, pi, like the circle constant?
That's right.
What's that doing in an infinite sum of squares?
That was the mind-blowing part.
Okay.
Euler proved that the exact sum of that series was pi squared divided by 6.
Wow.
It was a totally unexpected connection that revealed this hidden link between these seemingly unrelated areas of math.
So he's not just solving a problem.
No.
He's uncovering hidden connections, revealing a deeper structure of math.
That's Euler for you.
So his solution to the Basel problem was a stroke of brilliance.
Absolutely.
It must have sent shockwaves through the mathematical community.
Oh, yeah.
Euler was becoming a legend in his own time. St. Petersburg was clearly fertile ground for Euler's genius.
Yeah, it was.
But his journey didn't end there?
It didn't.
So new city, new challenges, new discoveries.
Let's go.
What was in store for Euler in Berlin?
Berlin was a hub of intellectual activity, and Euler thrived in this environment.
I bet.
Yeah, he continued his work on analysis and number theory, but he also ventured into new territory.
Like what?
Like geometry.
Ooh, geometry.
The study of shapes and spaces.
I remember drawing triangles and circles in school.
Who doesn't?
What kind of geometric magic did Euler conjure up?
One of his most famous geometric discoveries is known as the polyhedra formula.
Polyhedra formula?
Yeah, it's the simple equation that connects the number of faces, edges, and vertices of any convex polyhedron.
A convex polyhedron. Can you break that down for us non-math wizards?
Okay, so imagine any solid shape where all the faces are flat polygons.
Okay.
And if you connect any 2 points inside the shape with a straight line, that line stays entirely within the shape.
Okay.
That's a convex polyhedron.
Okay, so like a cube.
A cube.
A pyramid.
A pyramid.
Even a soccer ball. Those are all examples.
Yes.
So Euler's formula works for all those shapes. That's pretty amazing. What does it actually say?
It says that the number of faces plus the number of vertices minus the number of edges always equals 2.
Okay, so it's a surprisingly simple relationship.
Yeah.
But it has profound implications.
Yeah, it has implications for understanding the nature of shapes and spaces.
And what do we call that?
Topology.
Topology.
That's right.
So Euler's formula is like a secret code that unlocks the hidden truths about the structure of three-dimensional objects.
It's a great way to think about it.
And it all came from studying, like, basic shapes.
It did. It's really a testament to Euler's ability to find these profound patterns, even in simple things.
But his time in Berlin wasn't just about geometry.
That's right.
We were talking about his knack for tackling unsolved problems.
Well,
in Berlin, he encountered a conjecture that would become one of the most famous and enduring unsolved problems in number theory.
Oh, yeah.
Goldbach's conjecture.
Goldbach's conjecture.
Another challenge for Euler to sink his teeth into.
This one came from his correspondence with Christian Goldbach.
Okay.
Another prominent mathematician. And Goldbach had this idea, this conjecture, that every even integer greater than 2 can be expressed as the sum of 2 prime numbers.
That sounds pretty straightforward.
It does, right?
Yeah, 4 is 2 plus 2 is 6 is 3 plus 3 8 is 3 plus 5.
You got it.
So what's the problem?
Well, the problem is that no one has ever been able to prove this definitively.
Really?
We've tested it for countless numbers, and it always seems to work.
Yeah.
But there might be some giant even number out there that breaks the rule.
Okay.
We just haven't found it yet.
So Euler took on this challenge.
He did. He couldn't crack it.
Oh.
No one has.
Really?
Goldbach's conjecture remains one of the great unsolved mysteries in mathematics.
Wow.
This tantalizing puzzle that continues to inspire mathematicians today.
So even though he didn't solve it,
right,
his work on the problem and his clear formulation of the conjecture helped solidify its place.
For sure.
As like a central question.
Yes.
In number theory. It's amazing how a conjecture that seems so simple can stump the brightest minds for centuries.
It is.
It makes you wonder, like, what other mathematical secrets are still out there waiting to be discovered?
That's the beauty of math. There's always more to explore.
Speaking of exploration,
yeah.
What other avenues did Euler's mind wander down during his time in Berlin?
Well, he made significant progress in this field called the calculus of variations.
Okay.
It's a bit tricky to explain without getting too technical.
Try me.
Okay, so imagine you want to find the best way to do something.
Okay.
The shortest path between 2 points, the shape that encloses the most area with the least perimeter, the most efficient way to design a bridge. These are the kinds of problems the calculus of variations tackles.
So it's like optimization on steroids.
That's a great way to put it.
Finding the absolute best solution.
Yes.
Among, like, infinite possibilities.
Exactly. And Euler was a master of this.
I bet.
He developed powerful techniques for solving these problems. And he even showed how this connected to fundamental principles in physics.
Right.
Like the principle of least action.
Okay.
This principle basically says that nature prefers paths that minimize a certain quantity called action.
Okay.
And Euler's work helped to make that connection mathematically precise.
So he's not just doing math in a vacuum.
Right.
He's connecting it to the way the universe actually works.
He was deciphering the mathematical language of nature.
That's a great way to put it.
And to top it all off, Euler also managed to squeeze in some groundbreaking geometric discoveries.
More geometric adventures.
Geometric adventures.
I'm ready.
Okay, he proved this theorem about triangles.
Okay.
That's now known as the Euler line.
Okay.
It states that in any triangle, 3 special points, the centroid, the circumcenter, and the orthocenter.
Okay, slow down.
All right.
Back up.
Yeah.
What are those points?
Okay, so the centroid is the point where the 3 medians of a triangle intersect.
Okay, and what's a median?
A median is a line segment that connects a vertex to the midpoint of the opposite side.
Okay.
Think of it as the balancing point of the triangle.
I can picture that.
Okay, good.
What about the circumcenter?
The circumcenter is the point where the perpendicular bisectors of the 3 sides of the triangle intersect.
Okay.
It's the center of the circle that passes through all 3 vertices of the triangle.
Okay.
And lastly, the orthocenter.
Okay.
This is where the 3 altitudes of the triangle intersect.
Okay, and remind me, what's an altitude?
An altitude is a line segment from a vertex perpendicular to the opposite side.
So these 3 seemingly unrelated points.
Yeah.
The balancing point, the center of a circle around the triangle, and the intersection of these perpendicular lines. Euler proved that they always line up perfectly.
That's right.
That's kind of wild.
It's an elegant and surprising result that highlights this hidden order and beauty within even the simplest geometric shapes.
So Euler's Berlin years were clearly a whirlwind of discoveries. From the polyhedra formula to Goldbach's conjecture to the calculus of variations and the Euler line.
Quite a resume.
He really left his mark on the city.
He did.
And on the world of mathematics.
Absolutely.
But his journey wasn't over yet.
Yeah.
There was one more chapter to be written.
One more chapter.
One that would test his resilience and demonstrate the indomitable spirit of his mathematical mind.
That's right.
Intriguing.
It is.
I'm ready for the next chapter. Where do we go from here?
Well, let's find out.
So we followed Euler's journey from Basel to St. Petersburg, then to Berlin.
Yeah.
Tackling some of the biggest questions in math, publishing groundbreaking discoveries, and shaping the way we write and think about mathematics.
He did it all.
Where does this mathematical odyssey take us next?
Back to St. Petersburg, but this chapter is marked by personal tragedy.
Okay.
Euler loses sight in one eye.
Oh, wow.
And eventually goes completely blind.
That's heartbreaking. I can't even imagine the challenges.
Yeah, it's hard to fathom.
Did this setback slow him down at all?
Not a chance. Euler's mathematical spirit was unbreakable.
Wow.
He continued to work with even greater fervor, dictating his ideas to assistants.
Really?
His productivity seemed to actually increase during this period.
That's incredible.
It really shows his resilience, his passion for math, and the power of the human mind to overcome adversity.
It's almost unbelievable that he could continue working at such a high level despite losing his sight.
Yeah, it's remarkable.
What did he focus on during this later period?
One area that fascinated him was the study of Diophantine equations.
Diophantine equation?
Named after the ancient Greek mathematician Diophantus.
Okay.
And these equations involve finding integer solutions to polynomial equations.
Okay, so you're looking for whole number solutions.
Yeah.
To equations with variables raised to powers.
Exactly. They can be really tricky to solve. And Euler made significant contributions to our understanding of them.
So even though he couldn't physically see the equations anymore, he could still see their deeper structure.
Yeah.
Their hidden patterns.
It's like he developed a sixth sense for math.
He really did. Euler's mind was like a mathematical playground. And even blindness couldn't confine his imagination.
That's a great way to put it. He also explored this problem that sounds deceptively simple, but has deep connections to combinatorics and number theory.
All right, I'm intrigued. Tell me more.
Partitions.
Partitions, what are those?
It's all about figuring out how many ways you can break down a positive integer into smaller integers.
Okay, so for example.
Yeah, so the number 4 can be partitioned into 4 itself.
Okay.
3 plus 1,
Mm-hmm.
2 plus 2, 2 plus 1 plus 1, and 1 plus 1 plus 1 plus 1, 5 different ways.
Oh, wow. So it's like a mathematical version of breaking a dollar into coins.
There are lots of different combinations.
Yeah, and as the numbers get bigger, the number of possible partitions just explodes.
Right, and Euler developed methods for calculating these partitions, and he discovered some really surprising patterns.
It's amazing how he could find these intricate patterns in something that seems so straightforward.
Yeah, he was always playing a mathematical game, looking for those hidden rules and connections.
So despite these huge challenges, he never stopped exploring.
Never.
And during this time, he also continued to work with Bernoulli numbers.
He did.
Remind me what those are again.
So Bernoulli numbers are a sequence of numbers that appear in all sorts of places in math.
Okay.
From calculating sums of powers to this thing called the Riemann-Zeta function.
Okay.
Which has these deep connections to the distribution of prime numbers.
It's like Euler was this conductor.
I like that.
Orchestrating all these different mathematical concepts.
Yeah.
Finding harmonies and connections that no one else could see.
He was a master. Yeah. And despite his blindness, he continued to publish at this incredible rate.
Really?
Oh, yeah. He wrote influential textbooks on algebra.
Wow.
Calculus and mechanics shaping the way math was taught for generations.
So not only is he pushing the boundaries of math knowledge, he's sharing it with the world, making it accessible.
Exactly. That's a true legacy.
And he didn't limit himself to just pure math, did he?
Not at all. He tackled a really diverse range of topics. Optics.
Okay.
Astronomy, shipbuilding, even the theory of music.
Wait, music? That's fascinating.
Right.
What could a mathematician possibly contribute to music?
Well, he was a talented musician himself.
Oh, wow.
And he applied his mathematical skills to understand musical structure and harmony.
Okay.
And one of his key contributions was developing a mathematical model for musical temperament.
Musical temperament. I have to admit that sounds a little beyond my musical vocabulary.
So musical temperament is all about adjusting the tuning of intervals so that instruments can play in different keys and not sound out of tune.
Oh, okay, so you know how some notes just sound right together?
Yeah.
That's thanks to centuries of work on musical temperament.
Exactly, and Euler's insights really helped refine the system.
So thanks to Euler, we can enjoy beautiful harmony.
Without our ears cringing?
Yes, exactly. Another example of how his work touched so many aspects of our lives.
Absolutely. His work on music reflects his deep appreciation for beauty and order. In both mathematics and the world around us, he really saw math as this universal language.
Yeah.
A key to unlocking the secrets of the universe.
So we've covered a lot of ground today in our deep dive into Euler's world.
We have.
From his groundbreaking discoveries to his impact on the language of math and his unwavering spirit.
That's right.
So as we wrap up, what are some key takeaways about Euler's legacy?
I think Euler's impact on mathematics is immeasurable. He was a pioneer, a visionary, and a true master.
Yeah.
His work continues to resonate centuries later, influencing fields from physics and engineering to computer science and economics.
It feels like his legacy is about so much more than just equations and theorems.
You're absolutely right. It's about a way of thinking, a spirit of inquiry, a passion for exploration.
Yeah.
He showed us that math isn't just about memorization or solving for X. It's about finding patterns, making connections, asking what if. It's about the joy of discovery and the power of human curiosity.
It's truly inspiring to think that one person could have such a profound and lasting impact.
It is, and perhaps the greatest lesson we can learn from Euler is that limitations, even those as profound as blindness, can't extinguish the fire of a curious mind.
Wow.
He never stopped asking questions, never stopped exploring, and never stopped pushing the boundaries of human knowledge.
As we conclude our deep dive into Euler's world, let's remember his spirit of inquiry, his pursuit of knowledge, and his belief in the power of math to illuminate the mysteries of the cosmos.
Beautifully said. Go forth and Eulerize the world.
That's it for this deep dive. We'll be back soon with another fascinating journey into the depths of knowledge.
Until then, keep exploring, keep questioning, and keep diving deep.